how to take the high-speed video of this MAV having control points A1, A2, A3, B1, B2, B3, C1, C2, C3. So we have taken the video when the wind tunnel was turned on with some wind velocity and the supply voltage is given to the motor, so it had a flapping motion. But we wanted to check how the trajectories of the wing is happening when the wind tunnel testing is carried out. So we have taken the video. Now the post processing, as I mentioned in the last video, we have to do the post processing in another. As I mentioned, we have to do the video post processing in another software, and this is our wind tunnel. We have the calibration frame, so it we considered the wind tunnel external boundary as the calibration frame for the post processing, and we have used LED as markers, so it is bright, and when we take the video from high-speed camera, it is looking bright and clear, so that we can select each control points very clearly. 1 2 3 4 5 6 7 8 9. On the left side again same, 1 2 3 4 5 6 7 8 and 9. So there are 18 points. The software which we are going to use is Kwon 3D. It needs at least 17 points for 3D analysis, so we have 18 points which meets the requirement, and then the wind will come from this direction. Okay, as we can see, the MAV is kept here and it have the control points A1, A2, A3. If I play the video, then you can see the control points. So at some particular wind velocity, what we will do, we will give some supply voltage to the MAV and it will flap. So for the given voltage and given wind speed velocity, how the trajectory is changing, that's what we want to study in this software. So I hope the calibration frame points is clear, and also the wind, right, the axis from which the wind is coming is considered as x-axis, and the vertical from orange, green and red, this vertical axis is considered as y-axis, and from this red to this blue is considered as z-axis. So we have defined the axis, and we know the value from this orange to this orange. The length is 15 centimeter. From here to here it is again 15. So from the starting to here is 30 centimeter. Again the orange light, the first light, from here to the top is 30, and from the red color to the blue color LED again it's 30. So it's 30 centimeter cube. I want to show you the Excel sheet. We have defined the value from where we are taking 0 0 0, right? So let's see where is the first point, 0 0 0. The next point is 15 0 0. Third point is 30 0 0. As I told you, my origin is here, so this point is my 0 0 0 position. Then as I told you, this one, my x direction is here, so 15 0 0. The last one 30 0 0. So hope you understand how we have selected the points. Once we know our origin, then we can give all the control points by the axis what we see. Okay, so we have done this numbering of the calibration frame. So once we write down the calibration frame values, we don't have to type each and every time, just make an Excel sheet and save the time. Okay, we will use this Excel sheet values in the software. So now I want to show you the yes, these are the flapping wing video. So we can see the video very clearly at very low light because we have used the radium stickers, as I mentioned in the last video. Throughout the video we need to see all the 9 points, then only we can analyze each and single points, and it's very important um, to see all the points. Then only we can be able to find out if there is a wing rotation or what is the trajectory happening. These all things we can see very clearly. Okay, this is all about the video. And then now we will move to K1 3D, sorry, K1 CC. First we have to do K1 CC. K1 CC is calibration, um, yeah, calibration softwares, calibration setup. First we will go to new. Usually we go to new only, right? Then we have to set up a template. So I will explain what the template is. So we have taken the video with 3 cameras, and we have to add the cameras first. One, the camera 0 will be the camera 1. Camera 1 becomes 2. So now we have 2 cameras. The first, we have to give reference points and control points. Okay, no reference points, only control points. So we have used 18 points, as I mentioned, because we have used 18 LEDs. And if I click set, we get all the points, right? So what we can do, instead of typing all the values, we can go here, copy the value, sorry, yes, the value is copied, and I can click here and put the values. So my calibration frame is selected, and I click OK. And again, I don't want to give the control points, because we have given 18 points already, so it is already taken. So now I can click OK, and it will ask me the current template has been modified, update the template file. So if you want to save the file, it's better, because the next time you don't have to use the Excel sheet once again. And if you're considering the wind tunnel testing for each and every time for the post-processing analysis, then the template file will be very useful. For example, if I'm saving the template file somewhere near, okay, I can just save in some places. Okay, 30 centimeter calibration template, I just randomly saved. So now we can see x, y, z points, but x r, y r, z r, these things are missing. So we have to give all the values by selecting the control points of wind tunnel, and then we can see what is the value. So once we set up the camera, we have to go to image view. We can see 2 cameras, camera 0 and camera 1. So if I click camera 0, then it will ask for the videos. So now we have opened the file directory. We have 2 angles. So the first angle, calibration, okay, the file should be in AVI format, and the encoder should be DV encoder. If you use any other normal encoder AVI file, the software will not take up the video. So you must be careful about DV video encoder, then only the video can be imported. So the first calibration angle, I unselect the deinterlacing and I click OK. So now I can see all the 9 points. So as I know which is my first point, second point, third point, I told you the bottom, this is my origin, 1 2 3 4 5 6 7 8 9. So based on this I will select. So first of all we have to select digitizing mode, okay, digitizing mode, and then automatically on the right side we can see the blue color has shown. We have to select 18 control points. My first control point is here, so we can see the marker is generated. My second control point is here, third here, then green color is my fourth point here, 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 7, 8, 9. Then the green one, again, if we see the video, the green color is the 10th point, right? The video is not very clear, but we have, when we are doing the video capturing, we found out that this is the point here, the small light green you can see, right? So I can select 10, 11, 12. Keep your cursor as close as possible, then only the error will be very less. So I can select this one, this one, this one. Okay, so I have selected all the 18 points we can see on the right side. Then we have to select this rectangle, scan rectangle. If I select, we can see the dotted lines is created on the border of the screen. Okay, and I click cut. Then again I have to go to this one, second camera, and at this time we have to use second calibration angle frame. Again I unselect deinterlacing and I click OK. Now this video is much clearer, right? Much easier than the first video. So again I will go to digitizing mode. Now I will select 1, 2, 3, 5, 6, 9, 10, 14, 17, 18. So we have selected the 18 points, and then again we have to scan rectangle. We have selected this and click close. So now we have to calibrate the file. So what we will go to view, and then we will select calibrate option, and now we can see the values all has come, and the reconstruction error is 0.67. okay, so we have got very less reconstruction error. So now we have to save the calibration file. So I will click save, and now 30 centimeter calibration frame. Okay, so I will save this file. So now you have made the template, and we have made the calibration frame for the Kwon 3D software. So the purpose of this software is done. So we will close this software, and now we will select Kwon 3D. We have to open Kwon 3D, and again first we have to go to new and let it be here. Then again we have to go to setup, then model. We have to define our model. What is our model? Flapping wing is our model. And then if we come here, this software is actually based on the human body analysis for gait analysis and medical analysis, like how the joints and muscles are moving, and also this software is used for analyzing the human movement and angles when the golf player is trying to hit the ball very hard. So those parameters we have to define for human, but for flapping wing we don't have to do all those such things. Only we have to use is points and rigid bodies. Other things we don't have to worry. So as I mentioned, our flapping wing, sorry, yeah, yes, we can see 9 points: A1, A2, A3, B1, B2, B3, C1, C2, C3. So there are 9 points, right? So we have to mention add A1, then I have to give the color. Okay, yes, and radius is 1 centimeter. If I want to give 0.5 centimeter, and if I go to next for A2, have given red color, and then if I come again to A1 and see, the radius will be 0 centimeter. So that is why we have to use 1 centimeter, because that is the minimum size. Okay, I will go quickly add all the points. Okay, so I have selected all the points. I have created all the points. Now we have to create the link between each points. For example, if we see the video, this is point A1, right? So the point A1 is connected to A2 and point A2 is connected to A3, but the software don't take like this. We have to give A2 is connected with A1, then A3 is connected with A2. Okay, on this way we have to select. So I will show you how we select. So if I click A1, the connected points, I don't see any add option, but if I select A2, then I can see the pop out is come here, add. So I can select point A2 is connected point to A1, and the color which I set is black color. I want all the connected links as black color, and again we have to select 111. Okay, now A3 is connected to A2. The color is again black color, 111. Okay, now B1, um, let's see the video. Now B1, we cannot select because B1 is connected to B2. Actually B1 is connected to A1 also, right? So we can give A1 first. Now B1 is connected to A1, color is black, 111. Okay, now B2 is connected to B1, and B2 is connected to B1, and also B2 is connected to A2, right? Again I will add one more point, and A2, B2 is connected to B1 and also A1. So again I will select black color, I'll click 1 1 1. Now B3, I will add B3 is connected to B2 and the color will be black. Okay. And again B3 is connected to A3. Okay, similarly we have to do for C1, C2, C3. So I will quickly do it. Okay, so we have defined all the points as 111. let's just confirm from the top. A1 1, A2 is 1, and connected points are also 1 1 1, A3 1 1 1. Okay, yes, if we use the wrong values, then we will end up messing. Okay, okay, so now we have given the points, all the valid points. The next thing is rigid bodies. We have to give rigid body. What is the rigid body? So we are using this link, so we can see A1 and A2. So it is connected to A1 and A2. We will give some A1, A2. This cell is A1, this is A2. Similarly, we will add A2, A3, B1, B2, B3, C1, C2. This is just to connect the points. So wait a second. Okay, so now we have given the points and rigid bodies, so we don't have to give any other things. We will click OK, and it will tell us the model has been modified. Update the model file. So again, we don't have to create the model for this type of wingspan. For example, what we have used is 20 centimeter wingspan. So if we are using the same wingspan, we don't have to create a new template for the model, because we have assigned all the 9 points, right? So we can use the same for future use. Again, I will go to music, and we can give the file name as MDL. It will automatically save as MDL. Then we have to give okay, now we have defined the model file. Now again, setup, we have to go, then calibration. We have done the calibration in Kwon CC. We can import that file. Go to file, open, and then 30 centimeter calibration frame. I will open. We can see the files are imported, and we can see a reconstruction error of 0.677. Then we can see the two cameras, and then we will click OK. Only after you import the calibration file, you can see image view and two cameras in the image view. So first we will go to camera angle. Okay, before selecting the video angle, okay, as I have mentioned, first angle calibration. Okay, so we have used video like 2.4 volt, actually 1 meter per second, and angle 1. So if your angle of calibration frame and your angle of video is different, then you will end up messing up the simulation. So both the angles should be same. So now I will again show you the file. Sorry. So we can use the videos. We have cut the videos based on the requirement. Back. Yeah, okay, so we have cut the videos for angle 1 and angle 2. Okay, so this is our first angle. I will open, um, and again deinterlacing, click OK. I'll zoom the video little bit, sorry. Okay, now if I click the calibration frame, we can see how our calibration frame is looking, right? We have 18 points, so I will untick, and our wing is inside the wind tunnel, calibration frame wind tunnel. So what we are doing is, right, the next thing we have to do is digitizing mode again. As we can see, we have 114 frames. We can take each frames and select 9 points. So after I click digitizing mode, we see 9 points, right? So we have to precisely give the points location where the radium sticker is there: A1, A2, A3, B1, B2, B3, C1, C2, C3, and then this is next frame. Okay, if I click next, so again we have to select the points like this. So you can consider, for example, instead of considering 114, if we are considering around 100 frames, 100 into 9, we have to select 900 times, right? So it will take a lot of time. So to save some time, we use some gap between some frames. If I click here, it will, okay, now we have selected at the frame 0, so we have selected 9 points. If I again click here, it will automatically change to frame 5. Okay, but when the stroke reversal is happening, make sure, okay, remember this point, very important. When the stroke reversal is happening, make sure you you select one by one frame. Okay, then only at the stroke reversal you can see how the wing is rotating. But the other translation motion, it's not needed. You can go with 5 frames each. So after 5 frames I will go like this. So as you know, it will take a lot of time for me. We have done a model already, but this is how you have to select, and then later you have to select scan rectangle. Okay, then close. So for first video we have done. For second video, again second angle and de-interlacing. Now we will again see the calibration frame for our reference. Yes, so the calibration points and this video looks same, right? So we have used the points, and the wing inside is under the wind tunnel. So we will hide this and we will go to digitizing mode. Again we have to select A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, on the previous video it had 114 frames, but now we have 115 frames. So make sure, if you can make the video exactly with the same number of frames, good. If you cannot make the same number, it's okay. But what you have to do is, if you are able to select only 112 frames in the first video, so you cannot select 114 or 115 frames in select video. Okay, sorry, second video. Yeah, so in both the videos you have to use 112 frames, and then for the 112 frames only you have to select the points and digitize them. Okay, so again this is the same process, repetition, and scan rectangle, then click OK. Close the file. Then for data we have to go to raw data, then base trial, then compute. Okay, click compute, and again we have to go to data, compute all. Okay, so this is how we do the simulation. And now I will show you the one which we have done, because selecting 900 points for one video and again selecting 900 points for second video, so totally 1800 times, it will take a lot of time to select each points. So we have done something and I want to show you that. We want to show you the already existing file, and we have done this one with the same aspect. Okay, to zoom out, okay, control and mouse left click, um, trajectory. If I play, we can see the 9 points, right? We have assigned A1, A2, A3, B1, B2, B3, C1, C2, C3, and it have the trajectory, right? Now I am showing you only A1, A2, A3, sorry, not only A3, B3, C3. I'm not showing you any other points. Okay. But if I want to show you the other points too, what I can do is right click, then I have to go to trajectories, then which point I want to show. Now for example, I want to show A2, okay, B2 and C2. For A2, I want to set the ball color. Ball color, you can see one is red color, green color and magenta color. So for this one, if I want to select yellow color, okay, then the line color is maybe black. Okay, the ball size is 0.5. okay, let us, I forgot the value what we have used for the last one. Let us check with 0.5, and again for B2 I want to use another maybe light blue color, this one black color, and oh yeah, 0.1, 0.1. And C2, what we can do is maybe any other color. Okay, brown color, 0.1, and line color should be black. Okay, now if I click OK, I can see the other trajectory points too. So now let us play the video, and you can see how the trajectory is moving. So this is how we calculate the trajectories, and yeah, we can see the figure of 8 on each flapping motion, right? Yes, we can see the red color and yellow color. All the trajectory points of the wing have the figure of 8 motion. This figure of 8 motion is mentioned in the flapping wing trajectory wind tunnel testing, and a lot of method was used to find out the trajectory, but this is another method to find out the trajectory at some wind speed condition. So I will